Show of hands for those of you. I think it was James that shouted this out. Show of hands for those of you that have been on Leak Code before. Okay. How about Code Wars? Yeah, I don't like Code Wars. How about CSX? Okay, wonderful. So most of us have been on some sort of like algorithmic driven site, something along those lines. So most of the problems that you're going to find on these sites, especially a lot of the units that you'll find on CSX. I'm going to go ahead and mute everybody. Looks like somebody's still unmuted. Especially sites like CSX. Most of those algorithms, most of those challenges that say build a function that does X and then you have to solve for building that function out. Most of these are set up in a specific paradigm of programming. It follows a specific paradigm of programming. Essentially, that's a very fancy way of saying it. It follows a certain set of rules that are fundamental to, programming styles. And this style of programming is known as functional programming. Most of these functions and most of these challenges are set up as functional programming challenges. And functional programming has a lot of rules and things that are kind of associated with it, but not the least of which, kind of like the fundamental core rule around functional programming, is you should be building out your functions so that they are pure functions. Anika, can you remind me what is a pure function? Do you know?
That do not have side effects?
Yeah, it's a function that when you execute it, it doesn't have any side effects. And a side effect being, for those of you that are like, okay, well, what's a side effect mean? A side effect is a side effect means that when you execute the function, the only effect that that function has on your application itself is the thing that's returned out the bottom. Meaning that nowhere within the function itself does JavaScript reach outside of its execution context and affect some data elsewhere. When you have functions like this, it becomes very, very hard to debug large applications. If you have a function that has 300 lines of code and midway through that function, your function reaches outside and affects some data somewhere else. Well, if you have a bug, that means you have to go through every line of that code in order to identify where that bug is happening. But if the function is pure, meaning the only effect that it has is the return value, that just means that all you got to do is use Andy's favorite resource, the console, and log the return value to your console, and you can see exactly everything that you need to see. Makes it much easier to kind of debug through your large applications. Functional programming is extremely popular, especially over the last decade or so. But there is a different paradigm of programming that's been around for far longer, been around for, the last 30 years. Every major programming language, Java, Python, JavaScript, etc., has implemented this paradigm into it in some way, shape, or form. Now, this paradigm, though, follows an entirely different set of rules than functional programming. Functional programming, again, its fundamental rule, build functions that are pure functions. This other paradigm says you should be setting up your application so that you have data, the data in your application, all the data, and any functionality, any relevant functionality that could ever be applied to that data is right there next to it. Really easy to access. I don't know why I put weird emphasis on that word. Really easy to access. It's not like the functionality isn't like off in another utility file somewhere that you then have to import in or anything like that. It's just like data, functionality right there next to it. So this is a big piece for tonight because that paradigm of programming is, well, let's go to the crowd here. Sam, what is that paradigm of programming, man?
Object-oriented programming.
Yeah, you're damn right. Object-oriented programming, the thing that we're going to be talking about for the next 2.5 hours. So again, the fundamental purpose of tonight, if you're note takers, write this down, underline it, bold it, and I want you to also draw a quick picture. Data, the fundamental purpose of OOP, data and functionality right there next to it. Everybody just, because I'm saying it and I see some of you are very attentive, but then I'm looking at certain people and I'm like, they're not really paying attention. Everybody just do it with me one time. Data, put the hands up. Data, say it to yourself as well. Even if you're muted, just say data, functionality. Functionality. I like how some people are really overdoing the mouthing of the like, data function. Yeah. All right. So I'm going to be calling on you a lot tonight and re-quizzing you on the fundamental purpose of OOP. And that is it. I want to see the hands. I want to see the pantomime. I want to see data or data, whatever you say, and functionality. All right. So that's going to be our overarching goal for tonight, is to learn more about that fundamental principle of OOP. We're going to actually find, though, interestingly enough, that it's going to be pretty easy to do that part. It's going to be pretty easy to get data and functionality right there next to each other in JavaScript. What we are going to have a much harder time doing, though, is kind of staying true to some of these other principles within OOP. I kind of like to think of them as like the golden rules of OOP. So the fundamental purpose is data and functionality, but the golden rules of OOP is we should get data and functionality next to each other, but also it should be, for our application, it should be easy for us to add new features and functionality to our application. Number two, it should be performant, especially in terms of memory. We'll find out why that's important in just a second. And number three, like any paradigm of programming, it shouldn't be overly complex. It should be easy for us and other developers to reason about and understand how the application is working. So those are our three golden rules that are coupled very closely with data and functionality. Okay, so how are we going to kind of flex or work on our OOP muscles tonight? What we're going to be doing is we're going to be building an application, a mock application. We're going to be building a quiz game. And for tonight, this is going to be Anika's quiz game. It is Anika. That is how you pronounce it, right? It's Anika?
Yes.
Okay, just making sure. This is going to be Anika's quiz game. And Anika's quiz game that she's building is going to have, data and functionality. It's going to have users. So it's going to be, users are going to log into Anika's quiz game to, play the quizzes or, take the quizzes or whatever. So it's going to have users. And each one of those users is going to have associated data, such as their name, such as their score, and many other pieces of data as well. So the name of Will, the score of 3, the name of Tim, and the score of 6, et cetera, et cetera, et cetera. But we're also going to have associated with each one of those users functionality that we want to be able to apply to that data. So a very common piece of functionality in a quiz game would be the ability to increase the user's score. So, somebody gets a question right, we increase their score. We increase Will's score from 3 to 4 and Tim's score from 6 to 7, et cetera, et cetera. This is going to be the fundamental pieces that we are going to be building tonight in this application, following a very strict OOP structure. But before we start jumping into that, oh my goodness. I'm not a very big energy drink drinker, but this thing is giving me life right now. It's not very tasty though. Look at the flavor is Ultra Fiesta. What flavor is Ultra Fiesta? This is ridiculous. Very fun marketing ploy there. Users being able to increase the user score. In reality, though, I want you to make sure that you're keeping this in the back of your mind. In reality, if we're building out an actual quiz game, there is going to be tons of pieces of functionality, far more than just the ability to increase score. We're going to want the ability to increase score, the ability to decrease score, the ability to log the user in, log the user out, change the user's avatar photo, all of these different pieces. Taven, what's another kind of piece of functionality that you might find in a quiz game?
Like another piece of functionality would be like you can buzz in to answer a question.
Oh yeah, like hit the button, like you're competing against somebody else. There you go. Look at Taven's looking at V2 of this. It's like already competing against different people. Well, I guess if there's a score, you probably want to be competing against somebody. Let's see, Heidi, what's another one? What else would you probably see in a quiz game?
Like, try again? I don't know.
Try again. You get it wrong. You need to be able to like reset the count or like reset something so that you can like, answer another question. Sure, absolutely. Mai, how about you? What do you think? What would be in your quiz game?
I'm not sure.
No, nothing? All right.
Sorry.
That's all right. I'll be honest with y'all. This has absolutely nothing to do with the class. I just wanted to call on a few people just to make sure that y'all are paying attention. That's fine. That's all right. I'm sure that keep thinking on it. I'm sure we'll come back to it in just a little while and see what other additional functionality you want to add. All right. So this is what we're going to be doing. We're going to be building this quiz game. So we have, like we said we have data for the users, will, score 6, whatever the case may be. And then we also have functionality. So luckily, there is a construct or a data type in JavaScript that allows us to bundle up very easily data and functionality in the same kind of package, so to speak. Andy, what would that be, you think? What is that data type in JavaScript that allows us to bundle up data and functionality? I'll give you a hint. Okay. Think about the name of the lecture.
Oh, yeah, objects.
Objects, exactly right. Yeah, no, it's such an easy question that you're like, that can't be the answer, right? Yeah, objects. You can use objects to bundle up data and functionality. So before we start digging into the nitty gritty of how we're going to attempt to build out Anika's quiz game, let's first review some of the very generic pieces of how do you create objects in JavaScript. So here we go. This is probably the easiest way of doing it, which is simply to define an object literal. When you see an object that is literally like the open curly bracket here, the closing curly bracket there, and then key value pairs defined right inside of it, it's known as an object literal, right? Oh, you're just defining it right off the bat. So let's start working a little bit on our technical communication. For those of you that are new to Codesmith workshops, this is one of the things that we focus on primarily in hard parts, is building out your technical communication. A wise man once told me, if you ever want to master any skill, first master the vocabulary. Master the vocabulary, everything else becomes much easier. So that's what we're going to be attempting to do right here. So when you first start running code, like this bit of code that you see down here, I just copied all this stuff here and I pasted it down at the bottom. So when you start running code in your computer, JavaScript creates this thing known as an execution context. We're not going to spend too much time harping on the details of this because it's not going to be as important for this lecture, but we're going to touch base on just really quickly here. Let me unplug so I can draw. So JavaScript creates this thing called an execution context. It's essentially a space in your computer where it allocates certain space that protects it from other things in your computer that allows JavaScript to execute code. That's it. So the purposes of tonight, our entire whiteboard is going to be our global execution context. Global execution context. It's comprised of a few things. Let's find out what they are as Anika walks us through these first pieces of code. Best technical communication, Anika, what are we doing here?
All right. So we are in local memory. We are declaring a constant, user1,
okay,
to which we assign an object.
Perfect. So we're declaring a variable. We're saving some data. We need to save it somewhere. So Anika, where do we save data in programming or in JavaScript?
We save data in global memory.
Yeah, we save it in memory, and in this instance, it's global memory, right? Because we're in the global execution context. So here it is. It's over here on the right-hand side. Here's our global memory. And just as Anika said, we're declaring a user1 variable, and we're setting it equal to this object literal. Ooh, look at that. That was a great curly bracket. Let's see if I can keep that up for the night. Nope, there we go. The right one is always a bit harder. Okay, so here's our kind of our object literal that we've created. And what are the key value pairs on there, Anika?
Name is the key with will as its value.
Perfect.
And score is another key with 3 as its value.
Perfect.
Increment is a label for a function.
I love it. And this is how we represent, again, for those of you that may be newer to the hard part style of whiteboarding and lecturing, this function here that Anika is pointing out, we're going to take the function keyword is a command in JavaScript that essentially says, take everything all the way to this closing curly bracket here, take all of that code, don't run it, but bundle it up into a nice, neat little package and stick it in memory for usage later when we, invoke that function. And Anika, just remind me to be, oh, by the way, folks, this is how I draw functions. It's just this little box with an F on it. stands for function. So we just kind of indicate that that's all of that code bundled up into a nice, neat little package. Anika, though, remind me, it is a function, absolutely, but what is the technical term for a function when it's a property on an object?
It's a method.
A method, exactly. So for any of you that have ever been confused by that, kind of learning the ins and outs of JavaScript, you see sometimes it's referred to as a function, sometimes it's referred to as a method. If a function is just a standalone function by itself, it's a function. If it's attached to an object, it's a method. It's the only difference. Okay, wonderful. There it is. We got it. And then we have this little bit of code down here. I'm actually going to grab it. Copy that. Let's paste that up here at the top. This is going to be a very important piece of code we're going to come back to over and over and over again tonight. This is going to be kind of our test. This is going to be the code that we run to test whether or not we've accomplished our fundamental goal in OOP. And Nancy, remind me, what is our fundamental goal in OOP?
I forgot. Something about data and functionality.
There it is. That's right. That's half the answer. It's data and functionality. But what else did yeah, Nate knows it. What else did I say that you got to do with it, though?
Are you talking to me or Nate?
I'm talking to Nancy.
Oh, okay, cool.
You got to do the hand thing, Nancy. That's all I'm saying to do. So you got to data and functionality. That'll make sure that you never forget that answer. Data, functionality. If you do the hands, I promise you, you'll never. In fact, Nancy, just do it for me one more time. Just say, what is the fundamental principles of OOP?
Data and functionality.
There it is. There you go. I feel like you're a little bit lackadaisical with the hand gestures, but I'll take it. I promise you in an hour, I'm going to ask you that same question again, and you're going to know it just like that. It's going to be perfect. We're all going to love it. Okay. So this is going to be our test on whether or not we've accomplished that fundamental goal of getting data and functionality right there next to each other. Data being, let me change my color here. Data being user one, our object, that data. Functionality being the increment method. That's the function that's on that object, right? That's our method. Let's see if we can run the increment method on our user one data. Data and functionality right there next to each other. Okay, so here it goes, folks. Should we? Yeah, let's, yeah, why not? Let's do it. For those of you that know what's coming, go ahead and unmute yourself. For those of you that have no idea what's coming, just sit back and enjoy the magic that's getting ready to happen right now. Everybody, when we run a function in JavaScript, we create a new
execution context.
All right. Well, we got, let's see, we got maybe 7 people out of 58. I feel like that's not a great ratio, but it was correct at least. We get a new execution context. Everybody remember that one as well. If you're new, write that in your notes. When you run a function in JavaScript, you create a new execution context. Very similar to our global execution context, but it's like a little baby one. A little baby one. It's specifically for the execution of that function of increment, of our increment method. Excuse me. And it has its own memory space, but this time, instead of it being global memory, it's local memory. Local memory. Any data or anything that we create inside the execution of that function, not stored in global memory, it's stored in local memory. Okay. Now the code literally for this function, if I look down here, the code literally says user1.score++. User1.score++. That's the code that we're executing now. Fun thing, fun little tip here. Pro tip for being a great engineer. Not really, it's just something silly that I do. Pro tip, anytime you find yourself like thinking through like, what is happening here in this really complex piece of code? I like to think of like the inner monologue of what JavaScript thinks to itself. Like when it reads this line of code, what does JavaScript say or think to itself? Well, the fun thing is anytime JavaScript sees a piece of code and it's code that you wrote, well, I mean, I guess it's all code that you wrote, but we'll rather say it's not a keyword in JavaScript. It's not a reserved keyword like, the word function, the word return, the word const, all of these things are keywords in JavaScript. Anytime JavaScript doesn't see one of those words, it sees something else, it thinks to itself, it goes, huh, what the hell is user one? It sees user one and it goes, huh, what the hell is user one? I don't know what that, like it's not built into JavaScript. I don't know what user one is. So it has to go look for it somewhere. First place it goes to look is in local memory. Anika, do we see, or does JavaScript find user1 here in local memory?
Nope.
No, it doesn't. It doesn't. So where does it look next, you think?
It looks in the global memory.
Yeah, it looks one level outwards, right? It looks one level outwards. It looks in global memory. Does it find it there, Anika?
Yes, it does.
Yes, it does. Perfect. There it is. And then JavaScript sees that dot in between user1 and score, and it goes, okay, we're trying to access a property on the user1 object. So it then looks for a score property on the object. Anika, does it find it?
Yes, it does.
Yes, it does. And what does it do with the value that's associated with score?
It increments the score by 1, so 3 becomes 4.
Perfect. It sees that that plus plus is just a shorthand in JavaScript that says increment this number by 1. That's it. Okay. So we've accomplished our fundamental goal, data and functionality. We got much more to cover. So again, this is just a recap for those of you. I know I can see the glazed over look in your face right now. Where you're like, holy hell, did we really just spend 20 minutes talking about the execution of increment right now? Like that was a really long time. Trust me, I'm going into this much detail for very good reason. When we get into our much more complex pieces, if you're paying attention now, like I know Tyler is, like I know Isaac is, Taven, I'm not so sure. It could be, maybe. We'll see in a second. It's going to become much more natural. It's going to be very easy for you to track along. So you're going to go, oh, I remember the thing that Phillip talked about, the lookup process and, that kind of thing. Okay. So that's one very basic way of creating objects in JavaScript. There's a few others. Let's talk about them. Another way that you can create objects in JavaScript, you can use dot notation. Essentially what you can do is you can create an empty object literal here, and then you can add, kind of like in a separate process afterwards, you can add key value pairs to that what was an empty object using dot notation. So let's really quickly, let's paste that stuff up here. Let's go through that code very quick. Here it is. Let's continue on from our new piece of code, and let's see if Taven was paying attention. Taven, walk me through, man. What are we doing here in this first piece, starting right there?
Yeah, so the first thing, do we already have everything else set up? Global context?
Taven, I knew you weren't paying attention. God damn it.
Yeah, no, let me keep going.
No, I know, go ahead.
So the first thing that we're going to do is in global memory, we're going to create a new variable user2.
Perfect.
And assign it the value of an empty object.
There it is. Perfect. There it is. Oh, man, look at how bad that right curly bracket is. It's terrible. Okay, there it is. Keep me going, Taven. You're doing good so far. What's the next thing that we're going to do?
So then the next thing that we're going to do is with dot notation, we're going to assign it the property name.
Mm-hmm. And what are we going to set it equal to?
We're going to assign it the value of the string Tim.
Perfect. Next thing we're going to
do? With dot notation, we're going to add the property score.
And set it equal to?
Assign it the value 6.
Perfect. Next thing.
Next, we're going to dot notation, give it the method increment, and assign it to the function definition.
Perfect. There it is. So very similar kind of process that we had there. And just to be a little bit more specific, and I, by no means, Taven, do I want you to be this specific in kind of breaking this down, because I think you did it perfectly well. Use dot notation, add a property, set its value. But just as if we were going to go through that same process again of thinking through, like, how does JavaScript go through that lookup process a bit? When JavaScript hits this line of code, it sees user2. User2 isn't a keyword or anything, so it goes, what the hell is user2? And then it looks in memory. And when we were running that line of code, user2 was an empty object, but it finds user2 and then goes, okay, let's now add a name property to that user2 object. Boom, there it is. And then let's set its value to Tim. So it's just kind of like a multi-step process to load up with key value pairs that empty object. There's another notation in JavaScript that's very, very, well, I don't know if I'd say it's very, very common, but most people have probably heard of it before. Anybody know what that other notation that's commonly used in JavaScript is? Show of hands.
Bracket.
Oh, yep. Someone just jumped in and hit it. Yeah, bracket notation, whoever that was. Yeah, they're absolutely right. Bracket notation is, I don't know. It's not really the convention to use anymore, except for in certain instances where it's like necessary to use. Most of the time you'll reach for dot notation. Sometimes it may be more applicable to use bracket notation, but that's only when you don't know the name of the variable until runtime. So you're trying to, you don't know the name of the property until runtime. So you're trying to set a property based off a variable. It's whatever. You don't find yourself doing it too often, but in case anybody was ever wondering what's the difference, do a little bit of Googling. There'll be like 1,000 Medium articles that'll pop up and tell you what the difference is between bracket and dot notation. But it is something else that's out there. Okay. There's a bunch more ways. There's only one more way that I want to talk about in terms of creating objects in JavaScript. And I'm just going to go ahead and give it because most people won't guess it right off the bat because it's kind of an obscure way of creating objects. And it's using a method called object.create. It's a technique using a method called object.create. And object.create is going to ultimately, help us create objects. So I'm going to grab this code here and we're going to paste it up there in our whiteboard. We're going to walk through this bit as well and learn a little bit more about it. Now, I'm acknowledging the fact right now that one, some of you may have no idea how object.create works. That's all right. We're going to work through it right now. And two, we're going to be using it in a very boring fashion right now. We're going to come back to it in a much more interesting way later on, but right now we're just going to get like kind of the simple mechanics of object.create down. So let's go with, oh, Nancy's waving. I don't know if that's, you have a, oh, it's cleaning your screen.
Sorry, I got to jump out. I didn't realize it was over an hour long. Jake says hi.
Jake said, oh my God, Nancy, I know who you, now I recognize the last name. Oh my goodness, it's great to see, well, it's great to meet you. Is Jake there?
He's got a headache right now. But,
we'll just tell him I said hello. That's amazing. Okay. For those of you that are wondering what that's, Jake is Nancy's husband who came through in New York cohort 17, maybe, if I'm not mistaken, something along those lines. And now Nancy's going through the program. So wonderful to see you, Nancy. I heard that you're going to be coming into one of our future cohorts. So very excited to have you. Bye, Nancy. Bye. So where was I at? Using object.create. Let's walk through it. Let's go with Sam. Walk me through, man. Object.create, what's happening in this bit of code here? At least walk me through like what's happening on the left side of the assignment operator right now.
Okay, so we're declaring a variable user3 in global memory.
Perfect. Here it is. User, putting it down at the bottom because I don't have the room, but we're going to say user3. And we're going to set user3 equal to kind of whatever this piece of code here returns, right? Whatever that evaluates to. And Sam, even if you've never used object.create before, you've never seen any of this stuff, what would you just intuit, probably just by looking at the syntax, what object.create returns?
I feel like it'll return an empty object.
Yeah, it definitely will. It definitely will. Here it is. So we're going to set user3 equal to an empty object. So that's just all to say that this piece of code right here returns, it kind of evaluates to an empty object. Now, this part is important. I want to make sure everybody gets this. Kyle, you paying attention? Okay, just making sure. You have a very stoic look. I can never tell if I'm boring you or if you're just intrinsically like just there. I don't know. Object.create always creates an empty object. It has absolutely nothing to do with the fact that we're passing in null as an argument here. Nothing to do with that at all. We're going to find out what we can pass in there as an argument later that gives us a little bit more control over some certain things, but that's to come in just a little while. But for right now, just understand and know object.create always returns an empty object. Okay. Sam, you're doing well, man. Walk me through the next couple of pieces here. We now have our empty objects stored in, let me zoom out here, stored in global memory. What's the next thing we do?
Next thing we do, we set the property name, give it the value, Eva.
Somebody, let me, oh, there you go. I think they caught themselves. Go ahead, Sam.
And then next, we set the score property, give the value of 9.
Perfect. And finally?
And then we set the increment property to a function definition, which is a
there it is.
Increment method.
There we go. We set our increment method. All right, folks. Well, there it is. There's our 3 ways that we're going to be covering tonight about like how to create, just like kind of like a quick review on how to create objects in JavaScript. Now, again, there's many, many more, but we're not going to go through all of them. Ultimately, though, what we have here is different strategies or different tactics on creating objects, but ultimately still got us the same thing, right? Now we have in global memory, we have a user1 object that has a name, score, and increment property. User2 that has a name, score, and increment property, and then user3, name, score, and increment property, and so on and so forth. But the thing is this works, like this style of creating users, because again, these are all users in Anika's application, right, in the quiz game. This style works right now if Anika was just building this application for her and a couple of friends. Like it's pretty, easy to just kind of hard code out some of those pieces, not too bad. But we're not building this for Anika and a couple of her friends. We're building this application to scale. We're building this application so that it's going to be good for Anika, a couple of her friends, and 10 million other users. And fundamentally, right now, this tactic of creating user objects this way, of like hard coding, const, user1 equals, open bracket, closing bracket, add the properties. Const, user2 equals, so on and so forth, is fundamentally like untenable. It just will not work. It'd be the same thing as if Anika was the only engineer, and if this is the way that she was doing it, she'd probably be the only engineer because nobody would want to work on it. But if Anika was the only engineer on this application, that would be like if, OSHA came in and, late night, 10 o'clock at night, OSHA came onto Anika's quiz game to create a profile. And as soon as OSHA hit enter or submit on all of her information, Anika would get like a text message in the middle of the night, and Anika would go, "Oh shit, we have a new user in the application." She'd have to go look at the information, go over to her computer, and then type in, "Oh, who was the last user? Oh, user 4. Okay, now the OSHA is going to be user 5," and she would type that out. Like that's not sustainable, especially not for 10 million users, obviously. So we're breaking a fundamental principle in programming here. Tyler, what's that principle that we're breaking by repeating that process like over and over and over again? Remind me.
Dry, don't repeat yourself.
Yeah, the dry principle, right? DRY, don't repeat yourself. So, Tyler, what is the thing that we have in JavaScript that helps us solve the problem of when we're breaking the dry principle? It's a thing in JavaScript that allows us to bundle up some bit of code, give it a label, and then it allows us to execute that code over and over and over again without having to write the code over and over and over again.
We can use a function or an object.
Yeah,
well, no.
Yes to the first, no to the second.
Yes, a function, and I was thinking like storing a method within an object.
Yeah, we're going to talk about that. Yeah, we're going to get into those pieces as well. Yep, absolutely right. But the main thing here is we use a function, right? Function allows us to, take all of this code that we're repeating over and over and over again of creating these user objects, bundle it up, put a label on it. I don't know, maybe it's a label something like user creator. We create that function. And then when we execute that function, we pass in a couple of arguments. That function takes those arguments, such as the name of the user, the score of the user, creates an object, returns that object out for us to save. We don't have to keep writing the code over and over and over again. This is solution number 1. We have 4 solutions we're going to go over tonight. This is solution number 1. Let's walk through this code line by line, discover how this is working, discover the beauties of this tactic of creating Anika's quiz game this way. And then also talk about some of the cons, some of the drawbacks of using this tactic. So let's have, I actually already have cut it out. Look at that. I already prepared. I have global memory. I have my code cut out. It's right there at the bottom. Let's have Carlos. Let's have Carlos. Carlos, it's always a pleasure to have you on here with your bird. You're the only person that I've ever had with a bird during a lecture.
All right. So the first thing we would do, line 1, function user creator. We would save that into global memory, the function definition. User
Creator. So we're defining our user creator function in global memory. There it is. Boom. Wonderful. What's the next thing we're going to do?
We're going to be jumping down to declaring a constant variable labeled user1. And we're assigning that the evaluate result of user creator with the arguments of string will and number 3.
Perfect. So here's that code that you just walked through on that line of code, Carlos. And you said it absolutely beautiful, but just to kind of put a more, kind of visual effect to it, that's all to say that we've declared our user1 variable in global memory. There it is. we don't know yet what it's going to be set equal to. We don't know yet what it's initialized to. Initialize, the fancy word for set equal to. But what we do know is that we're going to execute this function here. We know that because of the, the parentheses. The parentheses say go execute code. And whatever's returned from this function is going to be stored inside the user1 variable. For now, it's undefined, or kind of not undefined necessarily, but kind of left uninitialized. When we get the return value, we're going to save that value in user1. Okay. Everybody, you should know the answer to what's coming next. So I want to see everybody unmute themselves on this one. Folks, we're executing a function in JavaScript, which means we are going to create a new
execution context.
Wow. It was like one person that had like that overpowering deep voice. That was wonderful, but had it absolutely right. We're going to create an execution context. Here it is. Make it a little bit bigger for this. All right. Here's our execution context. Execution context has its own, you know what? We should make that just a little bit bigger. Has its own local memory. And let's have my. Can you walk me through what is the first thing that we're going to do inside the execution of this function?
We're going to resolve our parameters with arguments.
Mm-hmm.
So we're going to have name is assigned to wheel, and the score is assigned to 3.
Perfect. And Mai, just remind me, which one of these things is the parameter and which one is the argument?
So the arguments are wheel and 3, and the parameters is name and score.
Perfect. Exactly right. Exactly right. Okay. And then what's the next thing that we're going to do after we've set our parameters and arguments?
We are declaring a const new user and set to an empty object.
Perfect. Here it is. New user set to an empty object. I have a feeling I'm going to run out of room here. We're going to see if we can squeeze it in. There it is. Next thing that we're going to do?
We're building up the new user object. So we're going to have a key name and assigned to name. Which is Will here.
Perfect.
And then the key score assigned to 3. And we are also having a method named or labeled increment.
Perfect.
Install the function definition.
All right, a bit messy there on my part because I didn't give myself enough room, but there it is. Perfect. And then the final thing we're going to do in this this code, Mai.
We're going to return the new user.
Yeah, we're going to return the value of new user. And what is the global label or the global variable that's going to kind of take that value and catch it?
We're going to assign it to the user1.
Yeah, we're going to assign it to user1, right? So user1 in global memory is no longer uninitialized. It's now this object. And on that object, we have name, which is Will, score, which is 3, and then increment, which is our method. Perfect. Perfect, perfect. Okay. And then we move on to the next line of code. Now, we're not going to go through all of this piece in much detail, but we can probably infer what's going to happen here. Let me move this down. It's fantastic technical communication, by the way, Mai. Let's see here. We're going to grab this bit of code. This is the next bit of code. Let's paste that up there. Mai, continue walking me through this. We're not going to go into all the detail, but just kind of walk me through what's the first part of this line of code. What does it say to do?
So we're just going to, so we are declaring user2, console user2, and we're assigning it to the value result of invoking user creator with the argument team and 5.
Perfect. And now again, of course, just want to make sure everyone's clear on this. We're going to kind of, do some hand wavy motions here. We're going to kind of gloss past some of these details. But of course, right now, JavaScript would open a new execution context, and it would go through all those steps again to create a new object that's going to be saved in user2. But just by looking at what we just did, Mai, what would you kind of just infer is going to be the value of user2 when that function is done executing?
So user2 will be the object, an object, sorry, with the key name and the values team.
Perfect.
And then we're going to have a score assigned to the value of 5, and then also a method with a function definition.
Perfect. Let's see here. There it is. Wonderful. So that's to say that by looking at that pattern, every single time that we execute our user creator function, we are going to get out an object that has name, score, which are going to be the values of whatever we passed in as arguments to that function, and an increment method saved in global memory. Let's do our test, folks. Here's our test. user1.increment. Let's go through this final line of code and see if we've accomplished our fundamental goal. Oh, and I would ask Nancy, because I said that I was going to ask her in about an hour, but she left. She left. She's running. Okay, let's ask, let's see here. Isaac, what is our fundamental goal again, man, in OOP?
Data and functionality.
Yeah, that's what I'm talking about, Isaac. Data and functionality. You got it on the first try. There it is. Isaac, when JavaScript hits this line of code and it sees user1, what does it do? Like, what does it say to itself?
It says, I don't know what that is. Let me check in my global memory and see if anything matches that.
Exactly. It says, like, what the hell is user1? I'm going to go look in memory, global memory in this instance, and see if there's something in there that matches that. Oh, look at that. There it is. It then says, okay, dot. So we're trying to reference a property on that object. It looks for increment. Does it find increment on the object, Isaac?
Yeah.
Yes, it does. And what does it do with it?
It opens a new execution context to run the function definition that's inside execute.
Yeah, absolutely, right. It executes the function. That's what the parens mean, executes the function. Okay, so we've accomplished our fundamental goal. So there's some pros and cons to this tactic of using a function, which, by the way, this tactic specifically, a function that whenever you execute it, it returns a new object. This is called a factory function in JavaScript. But this is our kind of step number one. We're attempting to build an EcoSquiz game using a factory function for each one of our user objects. There's some pros and cons. First, let's go through and let's answer any questions that we may have at this point. We do this, we show kind of our understanding with thumbs for those of you that are new. Thumbs up means I'm good to go on to the next thing. I have some questions, the sideways thumbs, downwards thumbs, I have no idea what's going on. Let's have thumbs from everybody on understanding what we've gone through so far. Thumbs. Hi, I'm proud. Anika's got a question. Good. Looks like Andrew's good. Taven's good. Sam's good. Mai's good. James is good. Carlos, how you feeling? Good. Okay. By the way, because I only have so many people on my first screen, so if I miss your question, I apologize if I don't actually see you physically with your thumb. If you have a question, throw up your virtual hand as well. If you go to the participants tab, there's a little button on there that says like raise hand, and that way I can see you even if you're not on my first screen here. Anika, let's go with your question first.
Back to the object.create method, you had null within the parentheses, and I'm just wondering, is that best practice that we should, if we don't have anything, we include null, or can we just leave the null out and it should be fine?
You can completely leave null out. I actually only put null there because it reminds me to tell you it has nothing to do with null. So yeah, it's not a best practice by any means. It's just something that I add there just to make sure that it draws attention to it. Good question though. Any other questions so far on where we're at? Nothing?
Yeah, quick question.
Oh, there we go. Andy, go ahead, man.
Yeah, what was factory function again?
Yeah, good question, man. So a factory function is a function in JavaScript that every time you execute it, it returns a new object. Execute it once, new object. Execute it again, new object. You can think of it as like it's a function that produces things over and over and over again, like a factory, which is why it's called a factory function.
Okay, so it's like a general term for the functions that act that way. Is that
Yep,
correct?
exactly right. It just describes a behavior that a function has. Yeah. Okay, folks. So let's talk about pros and cons for this. So the pros for this strategy, like solution number one, is it's super simple to reason about, right? We said that one of our 3 golden rules was it should be easy for us and developers to reason about. This is as simple as it gets. I mean, it may be a little bit complex to like get down the execution context, stuff like that, but you could literally see every last little piece of what's happening in this pattern, this strategy of building out our application. There are some cons though. Who thinks they know what the cons are for this strategy? Anybody have an idea? Anika, you know, what is it? What's one of them at least?
It's defining the method again and again and again, and it's the same method.
Yeah, exactly right? That's the biggest one right there that I hope everybody kind of noticed as we were going here. We have an increment method on our user2 object. We also have virtually the exact same function on our user1 objects. And OSHA's looking at me right now, very expressive face, OSHA. She's saying, yeah, but Phil, like, that's not that big of a deal. It's just this one little bitty function for increment. Yeah. And in fact, it's only one function. And also that function is only one line of code. It's literally just new user.score ++. Like, it can't be that big of a deal, right? But think about it. We have one function on 2 of our objects. That is not that big of a deal. But remember, we're not building this application for Anika and a couple of friends. We're building this application for Anika and 10 million users. So if we continue on in this pattern from user 1 all the way to user 10 million, we're going to end up having 10 million additional functions in our application that are all essentially just duplicates. But they're all going to be taking up their own space in memory. So it becomes unwieldy very, very quickly. But on top of it as well, remember, there are actually going to be tons and tons of other functions in here, such as the ability to decrease the score, the ability to log the user out, the ability to log the user in. Who did I say we were going to come back to? What was another one? Did you come up with another function that we're going to add in there?
Sorry, no, I was not.
It's like, no, I haven't even been thinking about it. Well, whatever it is, when Mai eventually comes up with the idea of something else, there's going to be that thing in there as well. So there's going to be hundreds of other pieces of functionality on every single user object, millions of user objects. So we quickly, tens of millions of additional lines of code. So this is fundamentally a big issue with this strategy. So what is the solution to this strategy? Well, I would say, just for a second, I know this will be tough because a lot of times people are in these lectures, they've been thinking about JavaScript nonstop for a very long time. I want everybody to take themselves out of like JavaScript mind right now. Like, don't focus on how are we going to do this in code or like how does this work? Just focus on like the sheer logic side of it. What I would say is if we had complete control over JavaScript and we could just do whatever we wanted, I would say what we could do here to solve this problem is we can create like another space in memory. Just put it in global memory for now, like an object. And we can take all of these functions like increment. See if I can just get this piece. I don't think I'm going to be able to. Oh, you know what? Let's see here. Oh, I got the drawing one. Okay. Grab this function. See if this works. Oh, there it is. Oh, kind of. No, that worked. There you go. Boom. We take that increment function. Man, I guess I didn't really think through this. Yeah, we don't have, essentially it comes down to, we don't have the increment function actually created on every one of our user objects, but rather we take those very common pieces of functionality that every user object is ultimately going to want to use. They're going to want to share those functions, and we put them in this other place in memory. So increment would go in here, things like login would go in here, log out, change user avatar, blah, 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 blah. All those common pieces of functionality. We stick them in this place in memory. And we call this place, I don't know, something like user function store, like the storage place for all of our user objects, common pieces of functionality. But then every single one of our user objects that we create, 1, 2, all the way to 10 million, we also create like this little bond. This little bond that ultimately connects our user object to our user function store. So it creates this link between our user object and our user function store, like common storage area. And then we tell JavaScript, we say, hey JavaScript, when you're going through that lookup process where you're like, what is user 1? And then you find user 1 and then you look for something on user 1. When you do that, if you're looking for a property such as increment, and let's actually walk through this really quick. So like you say, what's user 1? We look in global memory, we find user 1, we look for the increment method on the user 1 object itself, and you don't find it, JavaScript, if you don't find that property, don't panic. Look at the bond. Follow the bond to see if there is a bond, follow the bond and see what it points to. And if you find that function there, such as what we're doing here, we find increment there, wonderful. Just run that function. And that way we're able to create just one copy of increment and make it shareable essentially through all of our user objects. So we don't have 10 million copies of increment, we only have one. Okay. Anika, how are you feeling about this strategy? You think this is gonna work?
Yeah, I think it will work.
Yeah, it looks good. It'd be really weird if I explained all of it and like that wasn't gonna work, right? All right, let's figure out how we're gonna do this though, because I know a lot of the questions right now are probably like, okay, well that all sounds dandy, but how the fuck do we actually do that? Like, how do you, what is this bond thing? Like you're just making shit up now. How do you create the storage space? How do you create the bond? How do you tell JavaScript to follow the bond? Like where are those things? Well, let's talk about it. Actually, the way that you create the bond, we've already seen. We saw it in a very boring way, but we said we were gonna come back to it and make it more interesting. Remember the way that we said it was boring on how we were creating objects? We'd come back to it when it's more interesting. Tyler, do you remember what that strategy was for creating objects? It was kind of peculiar.
It was the .create.
Yeah, it was the object.create strategy, right?
Object.create.
Let me move back up here just for a second for that slide. We were saying object.create. Tyler, what did we say object.create always returned?
An empty object.
Always returns an empty object. Absolutely right. I wasn't lying. This is always going to return an empty object. 100%. Every single time. But when you actually switch this null out for something else, like user function store, if you pass in an argument to the object.create method, JavaScript is going to create for you. It's going to give you a little bonus piece of functionality. It's going to create for you that bond. We're going to find out more what this bond is in just a second. It's not actually called bond. We'll come back to that. But we're now just thinking about it as a bond. And that bond is going to be created, and it's going to attach itself to whatever you pass in as the argument to object.create. So if we pass in user function store as an argument, you know, the common space where we're storing all of our functions, the object that's returned from that object.create method is going to have a bond to user function store. And here's the best part. JavaScript already knows about the bond. It creates it itself. You don't have to, you don't type, new object.bond equals user function store or nothing like that. JavaScript just knows it's going to create that bond. It's a very special bond internally, automatically. And it knows that if it looks at that object and doesn't find what it's looking for, it's going to follow that bond that it created. So that may be a little bit weird right now to think about, but let's go to, this is solution number 2, by the way. Solution number 2 is using object.create to create that bond and kind of create that lookup process. So let's go through this code line by line. Here it is. I already cut it out. It looks a bit more, but it's really fundamentally not too much different than what we did before. Before, if you remember, we were simply creating our new user object and defining it, or we're creating it as just like initializing it as an empty object, literal. The only thing we've really changed here is now we're creating that object using object.create and passing to it user function store. So let's go through it line by line. Let's discover how this is working. Nate from Brooklyn, my Park Slope brother. Go ahead. You said Park Slope, right? That's where you're at?
Yeah, you got it.
Love that area, man. Have you ever been to Negril?
Sorry?
Have you ever been to Negril on 4th
No.
Street? Oh, dude, you got to check it out. It's amazing. Amazing jerk chicken.
Cool. Will do.
All right. He's like, yeah, whatever. Let's just move on. Nate, take me through line by line. What's happening in this code here, man?
So we're declaring a new function, user creator, which a reference to is stored in global memory.
All right. We define our user creator function in global memory. There it is. Perfect. Next line of code. What does it do? Oh, you're still muted, Nate.
We declare a constant variable user function store.
User function store. Good. And what do we set it equal to? Nate, man, you keep forgetting. Yeah, there you go. You're good.
Yeah. What do we set it equal to? An object with 2 methods, 1 increment.
There it is.
And the value of that is another function definition.
Yep.
And then the same with login right after it.
Yep. So we create our increment method. We create our login method. There it is. stored on that function. Wonderful. Next line of code. What are we doing, Nate? Keep me going, man. You're doing well.
We declare a constant variable user1 as
user1
return of the function user creator, which then we execute, which opens a new execution context.
Oh, Nate, come on, man. You're stealing the thunder from the class. Absolutely right. There it is. Hold on. I'm going to grab this code. I'm going to paste it up at the top so we know exactly what we're working with here. Say that whatever is returned, we're going to execute this function right now. Whatever is returned from this function is going to be stored inside user1 in global memory. Okay. I feel like it's been a minute. Let's go ahead and do it. Everybody, unmute yourselves. We are executing a function in JavaScript, which means we're going to create a new
execution
context. That's right, an execution context. And now let's mute everybody again. Okay. Here is our execution context. I'm going to use my fancy one, my preloaded execution context. There it is. All right. And let's have James from DFW. What is going on in the execution of user creator? What's the first thing we got to do here? Oh, let's move this up here so you can see it.
So the first thing that we're doing is we're going to pair the parameters with the arguments.
Perfect. And what are my parameters?
Name and score.
Okay. And what is
the name is Will and score is 3.
Perfect. Next thing that we're going to do, actually, let me slow this piece down just a little bit for you, James, here, and let me make sure that we map this out. So next line of code is going to be this. I'm gonna paste it right here, just so we can really keep track of like where it's at. Okay, so this is the line of code now that we're running. Walk me through this line of code, James.
Okay, so we're declaring a variable new user in the local memory.
Perfect.
And then we're going to set it equal to the evaluated result that comes back from calling the object.create.
Yeah, this is wonderful technical communication, man. And James, what did we say is always returned from object.create?
It's going to be an empty object.
It's going to be an empty object. Absolutely right. But because we're using the object.create strategy, method, whatever you want to call it, technique to create the object, and we're passing to object.create user function store, which by the way, again, is our object here in global memory, what is JavaScript going to automatically give us with that empty object, James?
It's going to have the bond. So we're automatically going to have access to those two methods that exist.
Give us that bond, and that bond is going to point to user function store. Wonderful. Okay. Next thing that we're going to do, James.
So the next line is we're going to add a name property onto the new user object in the local memory and assign it a value that is equal to the name that is stored in the local memory, which is Will.
Perfect. Next thing it's going to do?
Now it's going to repeat that process and set a property score, set it equal to 3, and then we'll return the new user, and I think it gets stored under the label user1.
You're absolutely right. Absolutely right. And fantastic technical communication as well, James, man. I love it. Here it is. So now our user1 is no longer uninitialized. It is now this object. Let's write it out here. Oh, those curly brackets get worse and worse as the night goes on. All right, here it is. Here's our object with a property name set equal to Will, score set equal to 3. And just because it was, returned from within another function, like it's returned from a function, doesn't mean that we lose the bond. The bond is still there. It gets returned with it. We have our bond. It still connects us to, or still points to, user function store. Okay. James, what's our next line of code going to do, man? We're going to speed through this piece a bit, but what's our next line?
We're going to declare a variable user2 in global memory, and then sort of repeat the process all over again.
Yeah, exactly, right? Here's just for anyone who's looking, here's the line of code that we're on. We create our user2. We're going to initialize it to the return value of running user creator again, passing to it now Tim and 5. Whatever that equals is going to be stored inside user2. So just kind of walk me through, James, without going through all the details. What is user2 going to end up being?
It is going to be an object with a name property equal to 10, a score property equal to 5, and it will have the bond to the user function store object.
Exactly right. There it is. So we have a name property equal to Tim, score property equal to 5, and we still get our fancy bond that points to user function store. All right, folks. Let's go through our final line. Our final line here is going to be our test. We have our two user objects all kind of set up with their fancy little bonds here. Let's move that down a bit. Here is our test, user1 dot increment. User1 dot increment. Okay, I'm gonna walk us through. You know what? No, I'm not gonna walk us through. Let's see here. Who looks like they're falling asleep? Todd. What's up, Todd?
How's it going?
How you doing, man?
Pretty good.
It's good to see you again this week.
Yep, definitely is.
Did you have a good week?
Yeah, it was pretty good.
Right on. What was your favorite thing about your week? Was it also the dropping of Taylor Swift's album?
No, it was actually, I figured out something in coding, so.
Hey, there you go. I can't complain with that. Todd, walk me through this lookup process right here, man. We hit this line of code. JavaScript sees user1. What does it do?
It's going to first look in local memory.
Well, it's only got one, because we're running it globally, so it's not going to.
Oh, sorry, I see what you mean. Okay.
Yeah. So what memory space are we going to look in for user1?
Global memory.
Global, right?
Yep.
We're running it globally, so we're going to look in global memory. Does it find user1 there?
Yes.
Yes, it does. And then it goes, okay, dot increment.
Right.
So it's going to look for an increment property on the user1 object. Todd, is JavaScript going to find an increment property on the user1 object?
Let's see.
Let's look. Here's our user1 object. Is there an increment property on it?
I don't see one there.
No, it's not. But does JavaScript panic?
No, it's going to look somewhere else.
Yeah, it's going to look somewhere else. You're damn right. Where is it going to look, Todd?
Looks like it's going to look in user function store.
Yeah, absolutely. That's absolutely right. It's going to go, oh shit, there's not an increment method here. It's going to go, oh, but you know what there is? There's a bond. So before I panic, before I start throwing errors and stuff like that and saying, this isn't defined, this isn't a function, blah, 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 it's going to go, oh, you know what? Before I, freak out, let me first go check out and see what the hell's going on in this bond thing. So it's going to follow that bond and it's going to go, oh, bond points to user function store. It's then going to say, here we go. Here's the increment method that we were looking for. And Todd, what does JavaScript do with that increment method?
It's going to call it.
It's going to call it, exactly. And all completely by yourself, Todd. When we execute a function in JavaScript, what do we create?
A new execution context.
That's right. Okay, it's a new execution context. Here it is. That execution context has its own local memory, and the code literally inside of the increment method that's stored inside a user function store is right here.
Right.
This dot score plus plus. This dot score plus plus. Now, this is typically where I lose most of you. Or as soon as you see this, literally this, you completely you hate it. You're already like, I gave it a shot. I was with them up to this point, but now they lost me. Because no JavaScript engineers like the keyword this. It is the bane of our existence. There are so many rules associated with this. At this point now, it's funny now because now I catch every time I say this. At this point now, there's probably 7 or 8 different rules that are all associated with the this keyword in JavaScript. Guess what? We don't have enough time to talk about all of them. We're going to talk about 2 of them tonight. This is going to be the first rule that we're going to talk about. Not going to go into too much detail, so I apologize if you're really hoping to get a lot more detail around this. But I promise you, Google the rules of this in JavaScript, and again, there'll be like a billion Medium articles that outline all of the different implementations of this. But when it comes down to it, this rule associated with the this keyword is actually pretty simple. It goes like this. No pun intended. It goes like this. Whenever you are executing a function, I'm going to zoom in here. Whenever you are executing a function, like we're doing here, the function that we're executing is increment. Whenever you're executing a function that is attached to an object, Tyler, remind me, when it's a function attached to an object, what do we call it?
A method.
A method, exactly. Whenever you're executing a method, if that method is utilizing this keyword, this is always going to equal whatever is to the left of the dot. It's called the left of the dot rule. This is always going to equal the object that we are executing that method on. So in this instance, we're executing the increment method on the user1 object. If the user, so that's to say that when JavaScript sees, this, it's actually going to see it as user1. If this was not user1, if this was user2, when you execute the increment method, this would not be equal to user1, it would be equal to user2, et cetera, et cetera. But right now, it is user1. So we're going to execute user1 dot score plus plus. And then it really just becomes about going through our normal lookup process. JavaScript hits a line of code. It first goes, what is user1? It goes, I don't know what that is. So I'm going to look in local memory. It's not going to find it. So it's going to look one more level out. It's going to find it in global memory. There it is. Then I'm going to look for the score property on the user1 object. There it is. And it's going to plus plus it. It's going to increment it from 3 to 4. Okay. Now, hopefully that didn't stir up like a million questions about the this keyword. But that is all to say, because you may be wondering to yourself right now, you're like, wait, hold on a second though. Like I was good up until that point. Like, why did we have to change what we were doing before? Because before we didn't have to use the this keyword when we were, like on solution 1, where we were creating like an increment method on every object. But that was because every single object, the user1 object, had an increment method that was designed to increment the score of user1. User2 object had an increment method that was designed to increment the score of user2. But we said that was problematic because now you have copies of that function over and over and over again. But because we are now pulling that increment method off of every single user object and we're putting it in this common place to be shared amongst all of the user objects, we have to generalize that function so that it can be ran on user1. It can be ran on user2, it can be ran on user 10 million. And every single time we use it, we always know it's going to increment the proper score for the proper object. So this is why we have to reach for this keyword. Okay. Let's have questions on this. Let's have questions on implementation. That was a hard word. Number 2, which is to use the object.create strategy, create the object that creates the bond to user function store. And in user function store, we store all of the common pieces of functionality. Ultimately, what that gets us to do is that allows us to create not 10 million, but only 1 increment method. And allows all of our user objects, essentially any object that comes from the user creator function here, is always going to have a bond to user function store. So we can have 10 million objects in global memory. Every single one of them will have a bond to user function store, meaning every single one of them has access to the increment method. Okay, let's have thumbs on this, people. Thumbs up, I'm good to go. If you get this, I'm telling you, the rest of this is gonna be simple. I'm good to go. I have some questions which would be completely understandable at this point. I have no idea, also a bit understandable, maybe not, whatever, that's fine. Thumbs from everybody. Okay, James has got a question, good. Let's see, Rachel, how you feeling? Rachel, thumbs up, you're feeling good? Question? You got a question? Okay, we'll come to it. We'll come to it in just a second here. Sam is good. I'm just scrolling through to see everybody else. Oh my goodness. I just realized how many people are in this room right now that do not have your cameras on. Folks, you are missing out on life right now. You don't have your cameras on, you're not getting the full effect. I need to be able to call on you. Turn your cameras on, people. Don't lie to me. I know you have cameras.